Okay. Just hope that this doesn't fail miserably. Okay, so it looks like it's working to me. There you are. Can you see and hear me okay? I know my camera's not on because I don't have my lights up. Can you hear me okay? That's the main thing. Great. Okay. So let's talk about this airplane question. So your airplane is traveling in a direction in the air, but the wind is going against it and pushing it out of the way. Just like any other plane, when it's up in the air, the wind has problems with it, right? So our question is to find the components of the wind. Like what's its direction and speed, right? So in the picture here, we've got the ground speed and the air speed. So we need to break them up into components first, because the difference of them is going to be our wind speed. Does that make sense? That it's going to be the difference of our two vectors is going to give us our wind speed. Okay, good. So let's think about what our first one is, our ground speed. So I wrote a second set of axes here to just talk about the ground speed of the one vector. We've got 140 degrees, it's going 800 kilometers an hour, and it's going from the north, right? So 140 degrees is 90 plus 50. So if we go from this axis, it's only 50 degrees. So that's easier for us to do our triangles. So we make a triangle and we have our components, our xg and our yg. So with these two components, we can use our trig formulas to find our angles, or to find our values. So remember that this is 50 degrees in here, so I'll call it theta. Remember that sine theta is opposite over hypotenuse, so that would be y over 800. And then cosine will be adjacent over hypotenuse, so that'll be x over 800. And so theta is 50 degrees, so why don't we just write 50 degrees, 50 degrees. So then that means that y for the ground speed is 800 times sine 50. And x for the ground speed is 800 times cosine 50. So make sure your calculator's set in degrees and not radians. Because that's a major factor right there. We'll have 800 sine of 50. That is 612.83. And our x ground speed, 800 cosine 50, 514.23. So that's the x and y components for the ground speed. Does that make any sense? Is that too fast? Like, how is this so far? Okay, because it is just the same as we did with that last question. We've just got our hypotenuse. We're gonna find our components. Same thing. Now let's do it again for our airspeed. So I'm just gonna do it in purple so we have a different color, but it's gonna be the same thing. It's just gonna be different values, right? So y of our airspeed is gonna be 875 times sine of 58 degrees. And our x of our airspeed is going to be 875 times cosine of 58 degrees. So y airspeed is what? $742.04, and x airspeed, just type it into your calculator again, cosine of 50. 463 point, I'm going to round up, 68. So are you good with getting those values? Okay, awesome. So what we have here is we have our components, right? These are the components of our ground speed and our airspeed. Now, if they were the same, that means there'd be no wind, right? But they're not. So there's that difference. So even in our picture, there's this dashed line here. This is our difference. So we need to find out what the components are of this dashed line. Now, the only thing is, technically, our y's are negative because they are in the quadrant 4 portion of our axes, so they would be negative. So, how are we doing so far? Great. Great, great, great. So now we got to finish it, right? So I'm going to start a new page here and write down some values. So I need a quick little thing. X ground speed. Negative 742. Okay. So I'm going to hide this page while I make a new one. So now we've got two sets of components. We've got our y of our ground speed, so negative 612.83, and we've got our x of our ground speed, which is 518.23. And we've got y of our airspeed, which is negative 742.04, and our x of our airspeed. 463.6. Okay. Now we got to take the difference of the two. So in our understanding, we would be taking ground speed minus the airspeed to get the difference, right? We're going to go ground speed minus airspeed. And this is going to be component-wise, right? So ground speed would be negative 112.83 minus, or here, I'll write it component-wise first. We'll have, I should actually write it this way, xg minus xa, comma, yg minus ia. Doing good so far? So that will be 514.23 minus 463. And does the color aspect help you see the numbers as well, or is it a bit too confusing? Negative 612.83. And now we're going to subtract the negative 742. There. So what numbers do we get? 514.23 minus 463.68. 50. 5. And we'll get negative 612.83 plus 742.04 gives us 129.21. Okay. Now these are both positive which makes sense with our graph. Because remember, this bottom arrow was our like true path. This is our airspeed, and this one's our ground speed. And the wind is going this direction, so it's pushing us up. So the last thing, well, let me see find the direction and speed of the wind. So now we need the magnitude and we need the direction. So this is now, so we've got this coordinate point of our wind. So this is our wind here. This is our coordinate of your wind. If I draw a new one, and I'm actually going to make this a little bit nicer for you. Now, our wind is blue. That's going to be a bit easier. So we've got two components here. 50, which we'll say is like here. And 129, which we'll say is here. It's not accurate, but we'll say it is. Okay. This is 129.21. And that's our total distance is 50.55. How is this looking for you now? Perfect. Perfect, perfect, perfect. Okay. So now we are still missing the direction, and technically we're still missing like the magnitude, you know, like how strong is the wind. Okay. We need this value here. So this, I'm going to say the length of W. And we're missing this angle here. We're going to call it theta W. We're missing those two things. But we have the two side lengths. So we can use Pythagorean theorem and we can use like tangent. So Pythagorean theorem, it would be, if I just do it same as regular, this would be x squared plus y squared equals our r squared. And so that would be r. So just make sure it's nice and clear for you. So x squared plus y squared is r squared, which means that we can have our r, which we're looking for, our length of our wind speed, going to be the square root of x squared plus y squared. So the square root, I think I'm going to write this first, 50.55 squared plus 129.21 squared, square root. So let's see, what does that give us? I got 138. 0.74 is a wind speed. It doesn't seem too far out of the park. And direction. So tan of theta W is opposite over adjacent. So 129.21 over 50.55 implies that theta of W is equal to tan inverse of 129.21 over 50.5. Okay. So, how do you feel now? And for theta W, I got 68.63. That's word problems. Word problems are not short. That's for sure. And what was it? It was in kilometers per hour, wasn't it? Something like that. Was it in meters per second? Yeah, kilometers per hour. I mean, it feels high, but it doesn't. Do you have any other questions about this? Cool. Did you write everything down? Would you like a copy of these notes? Because what I do is I save these images as JPEGs and I send them. Mostly put them in my Discord or send them. Perfect. And I don't have to worry. Great. And that was nice and quick. Okay, bye. I'll talk to you again.